Okay, folks, we're going to finish our lesson on binary ionic compounds, and there might be some noise in the background because Miss Fraser's working in here.
Hello, my people.
She's going to be on YouTube like that, and this is where we left off on Tuesday. So we've got the naming binary ionic compounds up here, and you finished the note. I'm using something new, so be patient with me while I learn how to play with this. Whoopsies, see? I'll use this. But I'll be writing with this thing. Okay, this is where we left off our note. Rules for naming binary ionic compounds. And this is going to be posted to Google Classroom, and you can look at this to catch up your notes if you didn't get it done on Tuesday. So binary, remember, bi means two. Ionic, we're dealing with two ions. And metals, LEP, GEN, lose electrons positive, gain electrons negative. So first part of the name always identifies the positive ion, which is the metal. Okay, we've got that in here. Metal cation. I wonder what would happen if I press that. Metal cation. Oops. There. Haha! Look at me go! Okay, metal is positive. Second part of the name always identifies the negative, which is the non-metal. Anion. Okay. When we are naming our non-metal, you change the ending of the non-metal to "ide." So let's look here at this example. We've got aluminum fluoride. That's our first example right here. Whoops. Aluminum, if we're looking on a periodic table and we go back to here, aluminum, I believe, is located right there. So if we're counting, +1, that's way too far, +2, go over here, it's going to have a charge of +3. A bit longer and slower than I thought, but that's okay because we're still learning. Okay, so aluminum has a charge of +3 and fluorine is a halogen. It has a charge of -1. Determine the total positive and the total negative charge needed to equal 0. So positive charge, if it's an Al, 3 positive, and a fluorine 1 negative, our total positive charge is going to be 3 positive because that's the amount, that's the largest amount, lowest common multiple, that they both go into. Whereas fluorine, we would have to have an overall charge of a 3 negative to balance that out. So one aluminum has a 3 positive charge, but we would need to have a couple of fluorines to get that 3 negative charge. So we've got fluorine, we need that one, and then we need that one. When we've got 3 negative charges, that's how we're going to get our fluorine. Note the ratios of cations to anions. It's a 1 to 3, 1 to 3 ratio. So 1, 3, and use the subscripts to show the ratio of ions. So it would be Al, aluminum. Oh, this, I'm going to have to work on my writing on this. So 1 aluminum and 3 fluorines. Okay?